Hello everyone, welcome to today's lesson on 9.2 Emergency Response for Chemical Leaks. For those of us working in the chemical industry, this is not just about acquiring knowledge, but also about ensuring life safety. Before we begin today's lesson, I'd like to assign you a task. Suppose a liquid ethylene leak occurs in the ethylene unit of your chemical plant. As a member of the emergency response team, you need to apply today's knowledge to develop an emergency response plan for liquid ethylene leaks. During the learning process, keep this task in mind and think about how to apply what you learn in practice. First, we need to define what a leak is. A leak refers to the unintended release of processed media into the surrounding environment. External leak, or an abnormal situation where one medium enters another through interconnected pipelines or equipment. Internal leak. There are two main types of leaks. The first is fugitive leakage, which typically occurs at sealed points of equipment such as valves, flanges, pumps, or weld joints on pressurized pipelines. Volatile substances unexpectedly escape from these locations. The second type is source equipment leakage, where materials are unintentionally and uncontrollably released from tanks, pipelines, vessels, or tank trucks. This type of leak is often an unstructured release. The hazards of leaks cannot be ignored. Depending on the type of leaked substance, leaks can be categorized as either flammable and explosive leaks, poisonous and harmful medium leakage. Flammable and explosive leaks may lead to severe incidents, such as fires and explosions. Toxic and hazardous leaks may cause occupational diseases, poisoning, suffocation, or even fatalities. To respond effectively to leak incidents, we need to classify leaks by severity. Based on severity levels, leaks are categorized into 4 levels: minor leaks, general leaks, severe leaks, and uncontrollable leaks. Each level has specific characteristics and associated risks. For example, a minor leak includes seepage at static seals without visible droplets, and dripping leaks, more than 1 drop every 5 minutes, as well as dynamic seal leakage of up to 5 drops per minute. A severe leak refers to static seal leakage at a rate of 0.5 drops per second or more, where the droplets form a continuous stream, or dynamic seal leakage exceeding 10 drops per minute. Next, we will discuss the general procedures for handling chemical leaks in detail. The process mainly consists of 4 steps: detection, isolation, containment, and decontamination. Let's start with detection. Detection is the first step in responding to chemical disasters. Its purpose is to identify the type of hazardous chemical involved in the incident, determine the concentration levels, and establish the hazardous area boundaries and required protection levels. Additionally, detection helps determine appropriate control measures, guide the treatment of poisoned individuals, and select suitable decontamination agents. There are 2 main methods of detection. The first is instrument testing, which involves sampling and analyzing data using detection instruments to identify the type, concentration, and affected area of the leaked substance. The second method is inquiry-based investigation. It involves questioning fixed sources such as managers, technical personnel, and workers, as well as mobile sources such as cargo owners, drivers, and transport experts. This helps gather information about the leak. Additionally, safety data sheets (SDS) and chemical safety labels are used to obtain relevant chemical information. After a leak occurs, establishing a safety perimeter is a critical measure. The accident site must define hazardous zones based on the extent of chemical dispersion to minimize casualties and to prevent secondary disasters. The perimeter should be determined based on the properties and quantity of hazardous chemicals, as well as the geographical and meteorological conditions of the site. Different types of hazardous chemicals require different safety radii. For example, the safety radius for flammable and explosive chemicals typically ranges from 100 to 500 meters, while the radius for radioactive substances is about 300 meters. Within the safety perimeter, we use different colored safety tapes to indicate different hazard levels. The area near the hazard source is the lethal zone, marked with red and white striped tape. The area between the hazard source and the first alarm point is the high-risk zone, marked with red tape. The area between the first and second alarm points is the low-risk zone, marked with yellow tape. Areas beyond the second alarm point are considered safe zones, marked with green tape. The response to leaks follows the principle of stop the leak, contain the leak, remove the leak. During leak handling, the following points should be noted. First, stop the leak source and rescue personnel. Personnel entering the hazard zone must wear proper protective gear. If the leaked substance is flammable, all ignition sources in the contaminated area must be eliminated immediately. First, the leak source must be stopped. If a chemical unit is leaking, emergency measures such as shutdown, recirculation, switching to auxiliary pipelines, or depressurization should be implemented. For leaks occurring during storage use or transportation, measures such as transfer materials, containment, or plugging the leak should be taken. Next, we need to select an appropriate handling method based on the leak's physical state and severity. For gas leaks, the following measures can be used: to spray mist water, to release inert gas, to neutralize harmful gases. For liquid leaks, the following measures can be used: collecting in containers, using absorbents, constructing dikes to contain spread, digging pits to contain the liquid, using pumps to remove spilled liquid. When handling leaks, different response strategies should be applied depending on the leak volume. Small-scale and large-scale leaks require different handling approaches. To ensure both safety and environmental protection, decontamination mainly involves cleaning personnel and equipment within the hazardous area to eliminate the impact of hazardous chemicals on people and tools. Decontamination must be carried out in designated decontamination stations or tents at exit points. Residual decontamination fluids must be collected and disposed of properly to prevent secondary contamination. The decontamination process must be repeated until monitoring confirms that no contamination remains. Now let's revisit the initial task assigned at the beginning. Suppose a liquid ethylene leak occurs in the ethylene unit of your chemical plant. How should you respond? First, conduct detection and inspection using professional monitoring instruments to determine the type, concentration, and extent of the leaked substance, as well as the hazardous zone boundaries and required protection levels. Then, based on the detection results, establish a security perimeter and deploy color-coded barrier tapes and warning signs. Next, proceed to the response phase. First, cut off the leakage source, then contain the spilled ethylene, and finally remove the leaked material. During the operation, ensure proper personal protective equipment (PPE) is worn and eliminate all ignition sources within the contaminated area. Finally, conduct decontamination, thoroughly cleaning all personnel, tools, and equipment within the secured zone to ensure no residual contamination. Next, we will watch a video to learn about the handling of liquid ethylene leaks.
Liquid leakage. In the actual ethylene production process, various liquid leakage phenomena may occur. Common liquid leakages include cooling circulating water leakage, green oil leakage, and liquid ethylene leakage, and so on. This micro-lecture takes liquid ethylene leakage as an example to explain the causes, phenomena, and emergency treatment methods of liquid ethylene leakage. Liquid ethylene, with the chemical formula ethene, is a colorless liquefied gas with a slight odor typical of hydrocarbons. It burns with a bright flame and emits black smoke. The flash evaporation and heat absorption of liquid ethylene can cause skin frostbite, and it is flammable. Its gas can form an explosive mixture when mixed with air, posing a risk of combustion and explosion in the presence of heat sources and open flames. Inhalation of high concentrations of ethylene can immediately cause loss of consciousness. The causes of liquid ethylene leakage are mainly divided into the following three categories: static seal failure leakage, such as gasket failure; dynamic seal failure leakage, such as mechanical seal failure; fault leakage, such as pipeline corrosion, and so on. The leakage of liquid ethylene can be judged from the following aspects: olfaction, unpleasant odor; vision, frosting at the leakage point, white smoke emerging from the leakage point; hearing, leakage sound; monitoring, acoustic and optical alarms from the combustible gas alarm. When a liquid ethylene leakage accident occurs, the treatment should be carried out according to whether it causes a fire. When there is no flame and the leakage amount is small and acceptable, the field operator should report to the superior, where a positive pressure breathing apparatus set up a warning line in the relevant area to prevent unauthorized personnel from entering. Continuously detect with a handheld combustible gas detector and wait for further arrangements. When there is no flame but the leakage amount is large and unacceptable, the field operator should keep a safe distance from the leakage point and not handle it blindly, as combustion or explosion may occur at any time. The field operator should wear a positive pressure breathing apparatus and fire-resistant clothing. Continuously detect the surrounding environment with a handheld combustible gas detector. Use a steam hose to purge and dilute the leakage point on site. To form an inert environment, control the impact range, report to the superior. Arrange for the leakage system to be shut down and isolated, and after pressure relief and passivation, cut off the material at the leakage point and wait for further arrangements. When there is a flame and the fire is controllable, keep a safe distance from the leakage point and do not handle it blindly. Report to the superior. Start the emergency plan. Have firefighting forces on standby. Arrange for the leakage system to be shut down, isolated, and passivated. Then cordon off the leakage point. Maintain positive pressure throughout the isolation period. The field operator should wear a positive pressure breathing apparatus and fire-resistant clothing. After the flame extinguishes by itself, purge and dilute the leakage point. To form an inert environment, control the impact range, set up a warning line in the relevant area. To prevent unauthorized personnel from entering, and wait for further arrangements. When there is a flame but the fire is uncontrollable, This situation is a fire. Immediately report and evacuate to a safe area. Start the emergency plan. Evacuate personnel and call 119. The factory should be shut down urgently to prevent the fire from spreading further. And cooperate with firefighting forces in rescue operations. This concludes the study of this micro lecture. Let's summarize the key points of this lesson. First, the causes of liquid ethylene leakage are mainly considered from two aspects: operational problems and equipment problems. Second, the judgment of liquid ethylene leakage is carried out from the aspects of olfaction, vision, and hearing. Third, the treatment methods for liquid ethylene leakage are respectively handled according to whether there is a flame after the ethylene leakage and whether the fire is controllable.
Today, we covered the definition, types, major hazards, and classification of leaks, as well as the general procedure for handling chemical leaks. I hope you internalize this knowledge and apply it in practice so that you can respond quickly and effectively to chemical leaks in the future. Thank you all for listening and participating. I hope today's lesson provides you with useful knowledge and guidance on emergency response to chemical leaks.